Namaste. I am Mrs. Arumugalakshmi.
Today we are going to discuss the problems in lesson 3 laws of motion of class 11. The first problem, a force of 50 Newton act on an object of mass 20 kg as shown in the figure. Calculate the acceleration of the object in x and y direction. So the given value is force is given as 50 Newton, the mass is given as 20 kg. We are supposed to find the acceleration in x and y direction. First let us find the component of force along x direction. We know the horizontal direction of the force because see the diagram here, the force is inclined at an angle 30 degree. Any vector which is inclined at an angle, we can resolve that into two components, horizontal component and vertical component. Horizontal component is the component along x direction. Vertical component is the component of force along y direction. So Fx is the horizontal component which is given by F into cos theta. F value is given in the question as 50 Newton. Cos theta value is given also in the question as 30 degree. So 50 into cos 30. Cos 30 the value is root 3 by 2. So 50 into root 3 the value is 1.732 divided by 2. The value is 43.30 Newton. This is the force. We have to find the acceleration. So we use our Newton's second law which is F is equal to ma. Here it is horizontal component. So Fx is equal to A into m. So A, reversing that formula we get A is equal to Fx divided by m. So Fx value is 43.30 divided by mass value is 20, which gives the answer as 2.165 meter per second square. Now we have to find the component along y direction. So the component along y direction, which is the vertical component, which is Fy is equal to F into sin theta. F value is 50, theta value is 30. So 50 into sin 30. Sin 30 we know the value as 1 by 2. So 50 into 1 by 2, which is nothing but 50 divided by 2, whose value is 25 Newton. Again using our Newton's second law, Fy is equal to m into Ay. Reversing this formula for acceleration, Ay is equal to Fy divided by m. Fy value is 25, m value is 20. So when you divide, you get the Ay value, that is acceleration along y axis. The value is 1.25 meter per second square. So we have found Ax value and Ay value, that is acceleration in x direction and acceleration in y direction we have found. Now the second problem, a spider of mass 50 gram is hanging on a string of a cobweb as shown in the figure. What is the tension in the string? So first given data is mass of the spring m is equal to 50 gram. Tension is asked. First let us draw the free body diagram. So for the spider which is shown in the diagram below, when you draw the free body diagram, the first and the foremost force is mg, which is acting in the downward direction. So opposite to this mg we have got the normal force. Here the normal force is given by the string through which the spider is hanging. So the tension in the string provides the normal force, which is opposite to mg. So how will you write the equation? The equation is written as T is equal to mg, where T is the tension which is acting in opposite direction to mg. So both are equal in magnitude and opposite in direction. So the equation of motion will be T is equal to mg. So from this equation, substituting the m value as 50 gram, g value, you know the g value as 9.8 meter per second square. Substituting in this equation, we get the tension value as 0.49 Newton. Now the third one, What is the reading shown in the spring balance? So two diagram is there. So first let us find for the first diagram. In the first diagram, the spring balance is hung from a rigid support and a load is attached to the other end. The weight of the load exerts a force on the rigid support, and in turn by Newton's third law. Your Newton's third law is for every action there is equal and opposite reaction. So in turn, that support, the rigid support also exerts an equal and opposite force on the load, so that the balance will be in a stretched form. So the answer will be, so since 4 kg is pulling down, the answer in the spring balance should be 4 kg. So the reading in the first spring balance will be 4 kg. Now move on to the second one. In the second one, the mass is given as 2 kg. And the angle is given as 30 degree. That is, the weight is inclined at an angle theta. If you see the diagram, you can understand the weight is not in exactly vertical down direction. It is inclined at an angle 30 degree. We know that any vector which is inclined at an angle theta, we have to resolve into its components. So here when you resolve, the two components are mg sin theta and mg cos theta. Here mg sin theta is acting parallel to the surface. That is, the weight, downward weight is balanced by the mg sin theta component. So how we write our free body equation as? W is equal to mg into sin theta. So m value is given as 2 kg, g value you know, sin theta, theta value is 30 degrees. So sin 30 is half. So substituting the value, when you multiply, you will get the weight value, that is the reading in the spring balance as 9.8 Newton. The next problem, a bob attached to a string oscillates back and forth as shown in the diagram below. Resolve the forces acting on the bob into its components, and what is the acceleration experienced by the bob at an angle theta. So here first let us draw the free body diagram. The free body diagram is shown below. So first and foremost force acting on the object is gravitational force, which is mg, which is acting in downward direction. It is inclined at an angle theta. Follow my pointer, you can find the answer. It is inclined at an angle theta. So any vector which is inclined at an angle theta can be resolved into two components, mg cos theta and mg sin theta. Mg cos theta is a horizontal component which is acting in this direction, and mg sin theta is acting in this direction. So first let us find the forces acting along y direction. So y direction we have got the force acting is mg sin theta. So this mg sin theta gives you the tangential force acting on the object. So finally the force mg sin theta is equated to the Newton's second law, which is m into a. F is equal to ma is your Newton's second law. So when you equate mg sin theta to ma, m on both the sides will get cancelled. Just follow my pointer. M on LHS and RHS will get cancelled, and the tangential acceleration, this acceleration, why it is called as tangential acceleration? This acceleration is acting in a direction tangent to the path of the bob. You know what is a tangent? Tangent is a line drawn to a circle which touches the circle at one point only. That is a tangent. Here the acceleration is acting along the tangent. So it is called as tangential acceleration, which is given by a suffix t, which is equal to, when you cancel m, you will have the remaining term as g sin theta. So tangential acceleration is given by g sin theta. Now the force is acting along x direction. So x direction you have got mg cos theta, which is acting in downward direction. Upward you have got the tension force, which gives you the normal force. So T is equal to mg cos theta is the equation along x direction. So the net force acting along x direction is T minus mg cos theta. This we have to equate to the Newton's second law, which is F is equal to ma. Here a is nothing but the centripetal acceleration, that is the acceleration towards the center. So m into a suffix c is equal to T minus mg cos theta. So we need to find the expression for AC. So m you bring it to equation this side. So the acceleration, centripetal acceleration, which is given by a suffix c is equal to T minus mg cos theta divided by m. So these are the two acceleration experienced by the bob at an angle theta. The tangential acceleration and centripetal acceleration. Tangential acceleration is given by a suffix t is equal to g sin theta. The centripetal acceleration is given by T minus mg cos theta by m. Question 6. Two masses m1 and m2 are connected with a string passing over a frictionless pulley fixed at the corner of the table as shown in the figure. The coefficient of static friction of mass m1 with the table is mu s. Calculate the minimum mass m3 that may be placed on m1 to prevent it from sliding. And m1 value is given as 15 kilogram, m2 value is 10 kilogram, m3 is 25 and mu s is 0.2. So first let us assume that m3 is the mass added on m1. So the maximum static friction value is given as F suffix S max is equal to mu Sn. This is the expression for static friction, that is the maximum static friction. So mu S into N is the normal force. Here normal force value will be equal and opposite to the gravitational force. So gravitational force is given by mg. The formula for gravitational force is mg for a single object. But here you have got two objects. So the normal force is given by m1 plus m3 divided by g. So n value I am replacing it by m1 plus m3 into g. So this equation you keep it as 1. Now, the tension acting on the string is given by T is equal to m2 into g. That is, along the string only m2 is hanged. So, in the m2, the force is acting is the gravitational force which is given by m2 into g. This gravitational force will be equal in magnitude and opposite in direction to the tension along the string. Just follow my pointer, you can find where the tension force is acting and where the gravitational force is acting. So the gravitational force m2g will be equal to the tension force. So T is equal to m2g. Have this equation as 2. Now we can equate these two forces. So these two forces will be equal in magnitude and opposite in direction. That is, the LHS of these two equations 1 and 2 are equal in magnitude. So we can equate the RHS. So when you equate the RHS, you have mu s into m1 plus m2 into g is equal to m2g. You can cancel g on both the sides. So the equation will be mu s into m1 plus m3. So mu s I am taking inside the bracket. So mu s m1 plus mu s m3 is equal to m2. Now I am taking mu s m1 to the RHS. So when it goes to this side, it goes as minus mu s m1. So already you have got m2. So m2 minus mu s m1. Now in the LHS, the expression is mu s m3. I am finding an expression for m3 alone. So mu s I am taking it to the RHS. So when it comes to RHS, it goes to the denominator, that is m2 minus mu s m1 the whole divided by mu s. So now I am dividing each and every term of RHS by mu s. So the equation becomes m3 is equal to m2 by mu s minus near m1 you have got mu s. So the denominator mu s will get cancelled in the numerator mu s. So the expression will be m3 is equal to m2 by mu s minus m1. We know the value of m1, m2, m3 mu as it is given in the question in the last line. So substituting these values and simplifying, we get m3 is equal to 10 divided by 0.2 minus 15, which is equal to 50 minus 15, which is equal to 35 kg. The maximum mass of m3 is 35 kg, which has to be placed on m1 to prevent it from sliding. But here we have got the m3 value is given as only 25 kg. So what will happen? The combined masses m1 plus m3 will slide through the string. The question 7. Calculate the acceleration of the bicycle of mass 25 kg as shown in the figure 1 and 2. See the first figure. 400 Newton acting in the LHS, acting along the left hand side, and the force 500 Newton is acting along the y direction. If you find the net force is towards the RHS. So if you can see the diagram, the cycle is moving towards the RHS, that is due to the 500 Newton force. So mass of the bicycle is given as 25 kg. The net force acting, you can find it is 500 minus 400, which is equal to 100 Newton. So the cycle will move in a direction towards the 500 Newton. So you can easily find the acceleration using your Newton's second law, which is F is equal to ma. So A will be equal to F by m. Here you have to substitute the net F value, which is 100 divided by 25, which is equal to 4 meter per second square. See the next diagram. In the next diagram, in the cycle, the forces on LHS and RHS are the same. That is, equal and opposite forces are acting on the cycle. So the cycle is static. It is not moving. So the net force acting on this cycle is equal to 0. Hence, you need not do the calculations. Simply, you can say that the acceleration is equal to 0. But still, we use the formula F is equal to ma to find the acceleration. So, A will be equal to F by m. Here, F value is 0. So, 0 divided by 25, the answer is 0. So, the acceleration on the second cycle is equal to 0. The eighth problem, apply Lami's theorem on a string shot and calculate the tension in each string. So, if you see the diagram, the force is given as 50 Newton and the angle formed is 30 degree. Here you can resolve the tension along the two components, which is T sin theta and T cos theta as shown in the diagram. So when you apply this Lami's theorem, we know that F divided by sin theta. Here the angle formed will be 2 theta. So F by sin 2 theta is equal to T by sin 180 minus theta. We know that sin 180 minus theta is again theta. So, T divided by sin 180 minus theta is equal to T by sin theta. Sin 2 theta, you know the formula as 2 sin theta cos theta. So, F divided by 2 sin theta cos theta is equal to T divided by sin theta. So, in the denominator, sin theta is common in both the LHS and RHS. So, you can cancel that. So, the equation will be F divided by 2 cos theta is equal to T. That is, if you reverse the equation, T is equal to F divided by 2 cos theta. We need to find the value of T. So, substituting F value, which is 50 Newton, divided by 2 into cos theta value is 30 degree. So, cos 30, you know the value as root 3 by 2. So, calculating the answer, we get 28.868 Newton. This is the tension force acting along the string. question. A football player kicks a 0.8 kg ball and imparts it a velocity of 12 meter per second. The contact between the foot and the ball is only for 1/60th of a second. Find the average kicking force. So mass of the ball is given as 0.8 kg, final velocity is given as 12 meter per second, and the time t is given as 1/60th of a second. So that is 1/60 second. Initial velocity is taken as 0. So the average kicking force is given by the formula F is equal to ma, which is your Newton's second law. Instead of a, we use the formula as change in velocity by time taken. So m into v minus u by t, where v is the final velocity and u is the initial velocity. Initial velocity is 0, final velocity is 12, m is 0.8. The time is 1/60. So substituting all these values and simplifying, we get the force acting is equal to 576 Newton. The 10th question. A stone of mass 2 kg is attached to a string of length 1 meter. The string can withstand maximum tension as 200 Newton. What is the maximum speed that stone can have during the whirling motion? If you see the stone, when it is just whirled, after when it is left, it goes along a tangential direction that you can see in the animation. So mass of the stone is given as 2 kg, length of the string is given as 1 meter, the maximum tension is 200 Newton. So you know the force acting on a circular body is the centripetal force. Here the centripetal force is provided by the string through which the ball is whirled. So the tension, the maximum tension is given by the centripetal force, which is given by mv squared by r. So here we know the F value, which is given as 200 and mass is given as 2. So substituting all these value, we have to find the maximum velocity. So reversing this formula, we have to find the v square value. So substituting F value, m value and r value, you can reverse this equation for finding v square, which is F into r divided by m. So F value, m value, r value, if you substitute, you will have 200 is equal to 2 into v square max divided by 1. So v square max will be equal to 200 divided by 2, which is 100. 100 is v square. So v will be equal to, you have to take the square root. So v will be equal to square root of 100, which is nothing but 10. So the maximum velocity is 10 meter per second. The 11th problem. Imagine that the gravitational force between Earth and the Moon is provided by an invisible string that exists between the Moon and the Earth. What is the tension that exists in this string due to the Earth's centripetal force? The mass of the Moon is given, distance between Moon and Earth is given. So if you see the animation here, you can see the Earth is rotating and you can see even the Moon is undergoing a revolution around the Earth. And you can see that invisible string which is given by the arrow. So there is a force between Moon and the Earth, which is nothing but the centripetal force. So using that centripetal force expression, we are going to find the force value. So F is equal to mv squared by r. M value is given, V value is given, R is the distance between them. distance between the moon and the earth. This is also given in the data. So substituting these values and simplifying, we get F is equal to mv squared by r, which is equal to 7.34 into 10 power 22 into 1.023 into 10 power 3 the whole square, the whole divided by 3.84 into 10 power 8, which is equal to 2 into 10 power 20 Newton. This is the force with which moon is attracted towards the earth. Twelfth question. Two bodies of masses 15 kg and 10 kg are connected with a light string kept on a smooth surface. A horizontal force of 500 Newton is applied to a 15 kg as shown in the figure. Calculate the tension acting on the string. So masses are given as 15 kg and 10 kg. The normal force is given as 500 Newton. The tension along the string. Already the motion of the object when it is connected. Likewise, the theory part we have discussed in the lesson. So, using that formula, the tension is equal to m2 divided by m1 plus m2 into F. m1 value, m2 value all are given in the data. F value is also given as 500 Newton. So, substituting all the value in this formula, we get the answer as T is equal to 10 divided by 25 into 500, which is equal to 200 Newton. 14th question. A car takes a turn with the velocity 50 meter per second on a circular road of radius of curvature 10 meter. Calculate the centrifugal force experienced by a person of 60 kg inside the car. We know that any object which is undergoing a circular motion, it experiences a centripetal force. So whenever there is a centripetal force, as per Newton's third law, every force has an equal and opposite reaction. So for this centripetal force, the opposite force is the centrifugal force which is experienced by the person who is inside the car. So that centrifugal force only we have to find. And the expression for centrifugal force is again, the magnitude is equal to the centripetal force. The centripetal force expression we know that the mv squared by r. So the magnitude of centrifugal force will also be the same. So we are using the same formula mv squared by r, substituting the mass value, velocity value, the radius of curvature value, we get F is equal to 60 into 50 square divided by 10, which is equal to 15,000 Newton. 15th question. A long stick rests on a surface. A person standing 10 meters away from the stick. With what minimum speed an object of mass 0.5 kg should be thrown so that it hits the stick? And here the coefficient of kinetic friction is given as 0.7. So the distance travelled is 10 meter, mass is given as 0.5 kg, coefficient of kinetic friction is 0.7. So first let us find the work done in moving the object in a horizontal surface. The work done is given by mu r into S. Mu r is given by mu into mg into S. So this work done will be equal to the initial kinetic energy. Kinetic energy we know the general expression as half mv square. So half mv square should be equal to mu into ms into g. So from this formula you can find the v square value as v squared is equal to mu ms divided by half m. So half mv squared is equal to mu mgs. M is there in both LHS and RHS, so you can cancel them. So if you find the value of v square, the half which is there in the LHS, when it goes to the RHS, it goes to the numerator. So the expression for v square will be 2 mu g into S. Substituting the mu value, g value, S value, we get the v square value as 14 into 9.8. So taking square root, we have got the value of velocity as 137.2.